Well, first of all, thank you so much, Roman and the anyLogic and anyLogistix team for having us today. We're really happy to present this presentation, which is the fruit of a lot of effort and was created from a partnership between a company from the industry and SimWell. So the title of the presentation is called Breaking Boundaries. We believe that we did so by doing this project in terms of the ALX usage for a real case of a business. So this is going to be presented mainly by me as a speaker today, but I'm representing SimWell. We are a leader consulting firm in supply chain optimization and simulation, and we are expert in implementing those advanced solutions as well. So today I have with me a colleague, Ershad, who's been very active on this project, more on the technical side as a modeler, who has been doing simply amazing, and also Mathieu, who is representing the industry leader. So and Mathieu is an expert in distribution network at the company that he's working for. We're not going to name the company here, but we're still going to talk about a bit of the industry. So today our goal, as you can see in the agenda, is really to express to you guys how we go from a real case scenario of business opportunity to creating a tool for making informed decisions. We're going to talk about the business opportunity, why we're thinking we're breaking boundaries in this case, what were the objective of the modeling effort. We're going to talk about also more on the technical side, what was the architecture used for this specific solution. We're going to deep dive also into technical challenges and obstacles that we want to share with you. And then obviously we want to express what is the value created around that modeling effort and what were the results and the next steps. So without further ado, I'm going to ask Mathieu to present a little bit more about this industry. So, I mean, Mathieu, would you like to express a bit more about your role within this industry, what kind of industry it is and how big? Give us a bit of idea of the scale, please.
With pleasure, Jean-Daniel. Thank you for presenting this. Unfortunately, I'm not able to share the name of the company for commercial reason, but I work for an established company, a very well-established company in the pulp and paper industry, founded in the 60s in Canada. The company is recognized for its expertise in manufacturing recycled packaging and paper product. Over the years, it has grown to become one of North America's largest manufacturer of recycled packaging and paper product. We offer a wide range of product, including corrugated cardboard packaging, food containers, hygiene paper product, and flexible packaging made of recycled plastic. In addition to that, the company is operating recycle sorting center in North America. So we get the fiber that become the raw material for our product and goes back into the manufacturing process. So trucks pick recycle bins and from household and families, as well as companies and industrial, again, to bring that fiber back into the manufacturing process. So we create a loop, a complete loop. So fully integrated manufacturing process. And we operate 70 different manufacturing sites with more than 8,000 employees in North America.
Awesome. Thank you so much. And as we can see also on the map over there, you guys are really spread out all over America. So that's very interesting as well. Now, I mean, so from Mathieu, from this industry that you're working in as the expert in distribution, warehouse, logistics, and everything. What was the main drivers? Like, why did you like come up with ideas on working with us, and what was basically the business opportunity around this?
The main driver for us was to first reduce the cost to serve our customers. So in terms of transportation, production costs, making sure we manufacture goods and store product and use the right mode of transport that reduce the costs for the company to serve our customer, create values for our shareholders for sure, and as well reducing the environmental impact. We are recognized for to be a green company, and so we use less energy and try to reduce the impact of our operation on the environment. That was, let's say, the three main driver. As we are operating in a very fast-paced industry, we knew at the time we had to rethink how we do things. So we needed a solution driven by data and the power of calculation of a computer to provide innovative strategies to challenge our traditional decision-making process and drive efficiency throughout our network. So to stay competitive, we needed that tool to use extraction from our ERP and other database to generate a better location of production for our customer and our products. So that solution also needed to update the result as the demand was changing, be easily updated, and also automate the output from our ERP system, and also easily implemented into the planning. So this is the part that is very unique about our solution, is that there's a way to implement the solution into the planning tool and put that into production as soon as we can. So really the goal is to present that methodology in this presentation.
Okay, well, I think it's well said, Mathieu. Thank you for that. It's a great wave to surf on for the next slide as well, which speaks about why we're thinking we're breaking boundaries with this one. And I think you said it perfectly. But if I rephrase a little bit, typically doing an anyLogistix project, it's mainly we're going to do an analysis based on different data we gathered, whether we do a pipeline or not. We're trying to aim to answer one specific question or a few questions at least. For example, where we're going to locate a new DC? Are we producing that set of products at the right facility, and stuff like that. But I mean, and what's great about this solution is that we believe we were able to break that boundary and achieve the tactical tool level. So basically, to be able to create a solution pipeline to redo this analysis constantly through time and be able to directly apply those solutions in the real life. So it's to basically making sure we're not missing on any opportunities. So the objective of this modeling effort, the key ones were obviously to create that technical tool, which revolves around network optimization mainly. But in order to do that, we needed to be integrated with the ERP system for data extraction and analysis to basically feed the ALX model. Then we wanted to optimize the product lineups and transportation methods. So basically, making informed strategic decisions based on that. So re-questioning all the time, like you said, Mathieu, basically it's a fast-paced industry, very highly competitive. So there's a major need for constant reevaluation of does that produce, like where should it be produced? Is it we had a plan, a forecast today, this is where we wanted to produce. In the next 4 months to a year might be a totally different picture. So there's a major need for that tactical tool to reevaluate. Again, other questions like shift, how, where, like what kind of transportation mode, and where should it go, through 2 DCs directly to the client, stuff like that. And supply from who, from which supplier, and all those questions we typically answer with network optimization, basically. Awesome. In terms of the high-level architecture, so this was also part of the objective. I mean, we in a super high level for the audience here that might not be too technical into those type of solutions. The typical process is to go from a forecast and performing some type of analysis, whether that's manual, a bit of automated Excel spreadsheets on the side and stuff, and then go into that planning phase where we know that we're going to execute that specific plan. But in this tactical solution, we're able to eliminate most of the manual analysis part and actually reduce that analysis time as well with this automated tactical solution, which we were able to do using anyLogistix. In a more detailed architecture and explaining a bit more around the technologies that we're using, we can see that there is the ERP system that we're not gonna say which one, but there's a data source which we use Python script to basically create that ETL in order to populate the ALX model. After that, we also have post-processing to basically making sure that once we're looking at the Power BI that we sent to Mathieu, that everything in the Power BI will be applicable to the production plan later on. So having that global solution allows us to go from the raw data to making the exact solution at the end, like to providing the exact insert which is applicable to the production plan. So the main application of this overall solution, like I mentioned a bit before, it's to be used on a quarterly basis. Also potential to be used every month or basically whenever we want. Whenever there's a change, as you can see at the bottom of this slide, we kind of had that phrase of saying, analyze this month, see the results in the next one. So it's kind of like a quick shift into this supply chain, but it basically allows to reevaluate whether there's a new transportation lanes that are available, different transportation mode on those lanes, if there's a new forecast, so it's a fast-paced industry like we mentioned. So if there's a big new customer in the industry, how is that going to impact the supply chain? So new forecast, new products, changing the cost because we want to optimize profit in this case. So if the costs are changing, external factors such as strikes in transportation industry, which we saw not so long ago, how would that be impacted into the overall supply chain? Then we can evaluate this. CO2 sustainability, like Mathieu mentioned. All of this is building supply chain resilience. So basically, being able to quickly pivot to those external changes. Now I'm going to ask Irshad to talk about a bit more, because we know it's an ALX conference over here. Like we want to talk also about the challenges and obstacles more in a technical way. So Irshad has done pretty innovative stuff in this project. So we want to make sure we put the spotlight on that. So Irshad, if you please.
Yeah, thanks, Eddie. So speaking about the technical challenges, so we can broadly classify them as data and computational. So we all know that anyLogistix requires the structured input data, like we need the information in well-structured Excel file, but businesses have different databases, like they can have multiple databases. So it was really complicated to get the raw data and convert into the ALX format with manual stuff. So for this challenge, we build the ETL tool in the Python, which take the data from all the multiple databases. Like sometimes some information is not available in the database, so that should be taken care by the manual information. So we need to integrate that in automated database along with the manual thing, so that we generate the input structure that can be fed into the ALX. So by developing the ETL tool in the Python, we taken care of this. And speaking about the computational, so each business is unique and does its supply chain, and we all know like each business has some unique constraints. So I just highlighted some of the custom constraint here. So one is like some customer can be multi-source for some product, but they should take at least 36,000 unit of the product from each source. So that was one constraint. And another constraint I want to highlight is like one customer should take one product only from the one source. So that was our business constraint, of few of the business constraint, and using the custom constraint feature in the anyLogistix, we were able to build that constraint. So next slide, JD. So here is the mathematical formulation of the first constraint. That is like, if the customer want to take from two sources, it should take at least 36,000 from each. So this is a mathematical formulation, and here you can see we were able to convert that mathematical formulation into the anyLogistix using the custom constraint feature. So first we created the variable using the label column in the product flow table, and for each variable, each flow variable, we created the binary variable associated with that using the big M formulation. And we added this two supplementary constraint so that whenever there is flow, it should be greater than 36,000 from each source. So that was about the first constraint. Next slide, GD. Yeah. And the second constraint was like one customer should take one product only from the one source. So in first screenshot, you can see like we sum the Boolean variable for one customer, one product from different DCs, and we sum that, we force that sum of the binary variable to be less than or equal to 1. But to get this binary variable from the flow variable, we use the formulation I highlighted in the first line. So this is normal big M formulation. So whenever there is flow, that binary variable will be 1. But whenever there is no flow, then the binary variable can be 1 or 0. But we are taking care of that using the objective function. So whenever flow is greater than 0, the binary variable will be the 1. But when the flow is 0, the binary variable can be 1 or 0. And as I said, that will be taken care by the objective function. But when we implement that, the model runtime was around 8 to 12 hours. So along with this big M formulation, we added the supplementary big M formulation in the, you can see in the second line. So when we add this constraint, our so this constraint is like previously we were looking if the flow is 0, then binary variable can be 1 or 0, and that we are taking care by the objective function. But here itself we are adding this complementary constraint. So whenever there is flow, the binary variable will be the 1. But whenever there is no flow, then we are forcing the binary variable 0 at the same moment. So we do not need to go in the objective function and check the objective function is maximizing the something or minimizing something. So when we add this constraint along with this constraint, the computational time drastically decreased from 8 to 12 hours to the 4 hours. So at higher level, like using the custom constraint feature in anyLogistix, we were able to develop a lot of business constraint, and that was very useful feature in anyLogistix.
Thank you, Rashad. That's awesome. I mean, like 8 to 12 hours to 4 hours. I mean, think about all the time you need to validate the model, make some changes. Like, so it's just press play, and then next day we're going to look at the results in the validation phase and everything. This was crucial. So really glad we were able to, that you were able to actually find this one out. So that's awesome. In terms of the overall, if we go back to, like we got really to the center of the solution, very technical. If we go up more a level, trying to wrap up this presentation a bit in the couple of next minutes, what is really like the value of doing all this? Well, the way that we use Power BI as a data visualization tool, but the way that it was built, we all know that in ALX, it's very important that validation with the subject matter experts. In our case, it's Mathieu with us. So providing a tool that is being able to rapidly validate the content of the output of ALX allowed us to perform a fast implementation of those results, which was a crucial part of the solution. And then when we talk about direct application, we don't just, it's not just in Mathieu's heads, you know, like it needs to be applied to the production planning. So we build a post-processing tool that which was developed in-house as well to basically match that production planning from the ALX output, which in this case was able to tell us exactly what quantity of product needed to pre-produce in which sequence, like exactly the exact trip of that special quantity for that specific product. Another mention about the result and the achievements. So here I'm going to go quickly on this. It's basically we want to express that this was about like a 6-month process. We're still going to work on it more and keep on improving it as I'm going to mention more in the next steps. But this was about a 6-month effort from nothing to creating this solution with about a 2-month implementation period on Mathieu's side. And over here you see the potential ROI of 3,700%, and you might ask, well, Jean-Daniel, do you know how to calculate ROI? Well, yes, in this case we do, but I mean, so just to touch base on this a little bit, it's really potential, first of all, because we need to then apply these changes to make it real. But second of all, there was a huge opportunity at the beginning because this type of work was not thoroughly done in the past. Now, the more that we do it in the future, then the less this ROI will be. But also, it's not going to take 6 months every time. The goal is actually at some point to press a button and to be able to confirm the full cycle of the analysis within a couple of days only. So just making sure we all agree on this. In terms of next steps, we want to, and here I put the word digital twin because from the beginning we're not talking too much about that, and I know it's it's the buzzword in the industry, and everybody has a definition for this, but it's slowly getting there in our minds, and we're not afraid to put it out there. But making a digital twin like this in every divisions, like Mathieu mentioned at the beginning, explaining the industry. We also want to improve the automation of the data extraction. There's always room for improvement in this case, and we know where the opportunities are. In terms of the CO2 emission, providing more insights and like dive deeper into that one as well. And then connecting all the digital twin together would be just a dream come true, which would allow to break those silos and create more synergy across the different part of the business. So that's about it for the presentation. I want to thank you all, and we're ready for answers. I think that I saw them popping a little bit, so more than happy to answer those.
Thank you guys for this insightful presentation and sharing your anyLogistix experience. So in real business projects, it was really interesting to know like how you suggest to reduce the computational time for optimization and how you troubleshoot all the challenges you faced. So it's really valuable for all of us, for all anyLogistix users. And in the Q&A section, there is a question. So how did you integrate Power BI with anyLogistix? So about the data flows and about the outputs.
Right. It's the transition from the ALX model to the Power BI is not automated. It's pretty much just a script in between creating all the needed files to be presented in the Power BI after. So it's basically using Excel in between Excel worksheets.
Thank you. And one question from our team. So for your project, when you're considering this planning cycle, right, feeding the model with data, how maybe I missed this, how frequently conceptually you would like to utilize this optimization cycle? So is it quarter planning or even more operational thing?
Well, and I might let Mathieu explain a bit more about this one, if you'd like.
We feel that on a quarterly basis is probably the sweet spot. Like, you don't want to run that model too oftenly because there's not enough changes to apply in production. But if you run it once a year, you might miss opportunities. So you need to find that sweet spot, and then for us, we feel that on a quarterly basis, it makes sense for us.
And what about the different parameters you update your model with? Is it only demand or something else? is being updated before the model run?
Well, usually demand for sure, demand, transportation costs, production
Mhm.
costs. Usually the constraint stays the same, but you need to feed the the inputs that are updated. New master data, new products, new customer, new suppliers.
Yeah, there are like many of the things of the parameters that are really variable in supply chains. So everything like a flat chat changes rapidly.